This is Unit 2, Lesson 2, Intersecting Graphs, and the objective is students will be able to solve systems of equations by graphing. We're going to start this out with a couple vocabulary words. One of the vocabulary words is one that you've heard a couple times. The other one is new. The first vocabulary term is solution, values that satisfy an equation. And we talked about solutions in our last lesson when we said that an ordered pair is the solution of a curve or any point that falls on a line or a curved line. A system is our new term, and that is a set of more than one equation. So when we are looking for the solution to a system of equations, we are looking for all of the solutions that fall on two curves at the same time. So down here we have three different graphs. The first one is an example of a graph that has one solution. So you'll see there's two curves, or a system of equations, and there's only one point where those two curves cross paths. That is the one solution. In the second one, we are going to show a graph with more than one solution. You'll see that there are two curves on this graph, and those curves cross paths in two different points. And then finally, if we were to have a graph with no solution, we have two curves, and you can see that those curves are never going to cross paths. Even if their graphs continued on after the arrow, they're going in a direction that they would never cross. So we're going to be finding solutions by looking at the graphs. We have two curves in this system. They are y equals 1/2 x plus 1 and y equals -2/3 x plus 8. So the first step we're going to take is the same step we started with yesterday, and that is solving both equations for y. The whole point of solving for y is that it just helps us graph, and you'll see that both equations already have been solved for y. So we can move on from our first step onto the second step, which is graphing both equations. When I graph both of these equations, I'm going to be looking for the point where the two curves cross each other's paths. Let's start out by graphing the first equation, y equals 1/2 x plus 1. So I start at my y-intercept of 1, and then follow the slope, which is up 1 over 2, up 1 over 2. In the past, I've always said you can just do 3 points. When I'm doing a system by graphing, sometimes I like to do more than 2 points because it just makes it a little more clear to me of where my lines are going to cross. So let's move on to the second point, or second line, and this line starts at the y-intercept of 8. So we'll count up 1, 2, 3, 4, 5, 6, 7, 8. And then the slope is -2/3. So I will go down 2 over 1, 2, 3. Down 2 over 1, 2, 3. Down 2 over 1, 2, 3. Really, we didn't need to do that fourth point because we can already see where those two lines or the two curves crossed. So this point we have right here is point 64. The point where the two curves cross. And that is actually the third step in our process. Step 3 was to identify the point of intersection. And now finally, since I have my point, I just want to check and make sure my solution is correct. So just like we did with yesterday's lesson, we are going to take the equation and we're going to substitute the solution to make sure the solution gives a true statement. Rather than doing multiple solutions into the same equation, for this one we have one single solution that we are going to substitute into multiple equations. So for my first equation, in place of y we have a 4. In place of x we have a 6, and then plus 1. And I know that the two cancels to a 1, 6 cancels to a 3. So what I'm left with is 4 equals 1 times 3 is 3, and 3 plus 1 equals 4, which is a true solution. And for the second one, we have 4 equals negative 2 divided by 3 times our x value, which was 6. Once again, we can cancel that 3 and the 6, so 6 will become a 2. And 4 equals negative 2 times positive 2 gives me negative 4 plus 8. 4 equals negative 4 plus 8 is 4. Once again, that's a true solution. So I've proved that the 0.64 is the solution to my system of equations. This is not only done with linear equations, it can also be done with exponential equations, just like we showed on this first example. We could graph an exponential equation and find the 2 points where the linear equation crosses. The only difference is that we graph an exponential equation using a different process than the linear equation. After that, we still look for those 2 points, or however many points where the line crosses.